Swayam Prabha. Digital India. Educated India.
Okay, now what we want to do is move on to putting some kind of real activities to what we are looking, and kind of discuss, how do we define these in cases like this. So I've actually given what I'm calling a simple shed, and basically what we have are the following activities. We have an excavation, we have construct wall and footing, construct actually footing and wall. So we have some kind of a foundation for this. There's a footing made, and then there's a wall made for the shed, and then there's roof rafters which are installed, and then we have installing the roof sheets, and then pass inspection, and then the job is done. So this is the basic 5 activities for constructing a simple shed the way we are defining. And now the question is, how can we do this? How do we represent these activities in a precedence diagram, so that we will be able to represent what is actually happening on the construction method? So like I have said here, the construction method becomes extremely important. If you are, for example, using prefab, the relationships might be totally different. If you are doing there can be a lot of variation on what the relationships are based on the construction method. And it's extremely important that you look at the method and understand the method properly before you start putting relationships which are representing of what's going to happen on site. So here we have really made a few, we have gone about and said, okay, we are going to start. So here you can see a start relationship and a finish relationship. So I will start excavation. After 2 days of excavation, I can start constructing the wall and footing. So this is the relationship I am defining, and wall and footing can finish only after 1 day after excavation is complete. That is how the finish 1 is defined here. Similarly, the installing roof rafters, we are saying that it will start only 5 days after the wall and footing has started. Okay, only 5 days after this activity has started, and can finish only after 1 day after this activity has finished. Okay, that is FF1. And installing roof sheets, we are saying after the rafters are installed, have been started, 1 day after the rafters have started, I can start installing roof sheets, and it will finish 1 day after the rafters have been after the rafter activity is completed, after 1 day after the rafter activity is completed. And inspection, we basically say after the installation of roof sheets is done, okay, it will be only after that inspection can start, and it will take 1 day. So this is the representation which we have discussed. And if you actually look as to how the shed is constructed, for example, I might say, I don't want to overlap. I'll do all my excavation, all my construction of footing, and then do the wall, and then install, and but obviously that would take a lot of time if we did every activity serially, and that's why we want to start this in a parallel way. Now if we were going to do the same setup using activity on node, okay, with just the finish start relationship, we would end up with a serial set of activities. Now the alternative, as we discussed last time in the last class, is to break it up into pieces, and in many ways that's a good alternative. If I'm going to take excavation and break it into excavation A1, A2, A3, and then B1, B2, B3, and C1, C2, C3, and based on how I'm going to do this, and then represent it in an activity or node with several activities, I think that you have to certainly handle more activities, okay, but that's an option which is possible. But if we are going to do it with a precedence diagramming method, this is how it works out, where you have your A, B, C, D, E, and all of the relationships which we discussed are defined here. So we have the start, okay, the finish with all the lags as we have specified in this, and we can now do the basic analysis which is shown here. So you have 2, again 17, and then you find as you so we get from the start relationship we get 2, go to 15 we get the 17, from the finish what we got was 8. So obviously 17 controls. So I am not again going through the details of this, but let us see how do we then represent and analyze this. So you will find that once we do the analysis, the critical issue, the critical aspects are: 1, this start relationship, so start of A becomes critical, the start of B becomes critical, end of B is critical, finish of A is not critical, start of C is not critical, start of D is not critical, but end of C and end of D become critical, and the start and end of E become critical. So what does this mean in terms of these activities? How does this translate into an actual implementation if on the field? So for example, if I say I am going to start excavating and then end of excavation is not critical, it means that it does not mean that I can start excavation and stop, because I have to keep excavation ahead of constructing the footing. So if I do not keep excavation ahead of constructing the footing, somewhere B is going to stop. So here you can see B is fully critical, but A is only the start is critical, but it does not mean that I start and then I stop A because I have got things started. From the network perspective, it might show that just start A and then everything can take care of itself, but that is not how it is going to work, and you will have to really know the physical layout and how the progress of A, the work front for A of doing A has to come to B. So that work front progress has to be planned and that detail has to be taken care of. Just because we have done this relationship, and we cannot assume that the event here will take care of all of the network. So this is very important. A just cannot emphasize it enough. A just what we have represented here is just a very abstract way of what the project is going to go through. Ideally, I should have more relationships here, which if you had done on the AON by splitting activities, you have those relationships. And so a lot of times from a very basic sense, that is easier and more intuitive to understand and control. So as we come down here again, so that is between A and B. Similarly, you can see that activity C, the start of C is not critical, but the end of C is critical. So while the start of B is critical, I can then start delaying, or I have flexibility with the start of C, but I have to end it on 18. Okay, so this is somewhat realistic as far as a subcontractor of C might want this kind of information. Okay, rather than saying, my whole of C is constrained within a particular range or things like that. And so one way of expressing all of these results, I have shown it in a tabulation here. So what we have is activity, we have the duration, we have the predecessors, we have here the early start, early finish, the late start, late finish. Okay, we have start float, finish float, and what we are calling as total float or activity float. Okay, so all of these values are listed here, and then we have again you can see this from the network. We have taken the relevant values for for early start, early finish, late start, late finish, as well as based on these values we have calculated the start float, the finish float, and the activity or total float. So you should be able to go through this tabulation and check with your calculations what answers you get and if they tally with this. Now at the second table here we have the relationship floats. So if I can go back and forth, so we have relationship, for example AB relationship here, we have a start AB relationship. Basically we are calculating it here with with 2 okay, being the value of the late start and 0 being the early start away minus 2. So, 2, okay, minus 2 is 0. So, this is what so similarly for if I take a finish relationship, okay, I have A B, again this is a finish with a duration of with a finish with the lag of 1, and I am looking at the bit I'm sorry, this is a yeah, here finish. So, we are going with 17 minus 7 minus 1, and that is coming from 17 minus 7 minus 1 gives you the float in this finish relationship, okay, and you can see that is a value of 9. So, basically this relationship can be, the lag can go, okay, an additional 9 before it starts impacting the project, that can be seen, and obviously this is also shared with the finish float of A. So, just as we had total float in the AON and it is shared along a chain of activities, these floats here are also shared based on how they are along the activities, okay. So, you have to be careful that it is not, again it is not like a free float, it belongs only to the activity, only to that part of the activity, okay. It is again shared along the path. And so, similarly we have all the finish floats represented here, and then we have this finish start, which was the only finish start relationship here was this one, and the finish start float is also now represented through this calculation. And obviously when we get I mean here it's pretty straightforward, we do not have a lag, it gets to 0, okay. So, this so ideally we would take a network representation like this, do the analysis and show it in a tabulation like this, so that it can be in a larger project this might be easier to read rather than do this, but from a conceptual standpoint I think this is fairly illustrative. That is why I have used more of the network for the result discussion rather than just the tabulation. Okay, now we come to the application issues. So, I think I have been repeating this from the beginning, that we have seen a lot of PDM being used, especially through the software that is available. Okay, the software that is available today is quite powerful, and we have seen a lot of planning groups use the start, finish with leads and lags quite liberally, but once they do that, you are not able to actually, nobody is able to interpret what is happening to the project. Okay, so unless you have really a lot of experience and you are able to represent the logic of what the construction method that is going to be used very accurately in the PDM, it is not advisable to use these complex relationships when you are starting out as in your planning exercise. Once you have experimented, tried, understood how the software behaves, how the logical relationship behaves, then by all means start scaling up the use of PDM, because it is certainly powerful, and the more we are able to use the power, the better our kind of the more representative will the plans be of the project in a much more compact way. But like we discussed, AON, given that we can't use AOA in software today, okay, most of the software will use an AON representative. You can use finish start relationships, and through that we should be able to actually model most of what we can do. The number of activities will certainly be more, but I think basically what our experience interacting with many of the companies have shown, that it is still reasonable place to start. Okay, again repeating, once you have experimented and you have understood how these other things behave, then you move on to PDM from a practicing point of view. Also, when you get to software, in fact I would encourage you to use any of the standard software and enter PDM and enter some of these what we call negative lags, leads. You will see the software itself does not give you reasonable answers. So, there is no standardization in the software. In addition to knowing the concepts in detail, you need to have a detailed knowledge of the limitations of the software itself. What is how the software computes what. And you will find that in addition to some of these constraints, you have constraints like must start on, must finish before, can start, must start after. All of these constraints make the software again very much more involved and complex to use. So, while I would like to end with this, while we have really analytically powerful approach in the PDM, you should apply it with care and do starts with the basics of PDM if you are implementing it on site, and then scale it up. Thank you.